Games like Pixel Art Academy uses drawing as a game mechanic, well, in this case to actually teach you how to draw pixel art. In this tutorial, I will show you how we can draw in Unity, but stick around because I will be diving into some advanced features from my drawing pixel art project template that you can find on my itch.io page. The link will be in the description. Hi, I'm Peter and welcome to Sunny Valley Studio. We will use RenderTexture as a canvas to draw on and to display it in our UI. I will create a new Unity 6 Universal 2D project. In the Projects tab, let's right-click, Create, we are going to search for Rendering, and here we should find the RenderTexture. We will draw onto this RenderTexture. Select it, and in the inspector we are going to set the size to be 16 by 16, press Enter to apply. We are going to set the filter mode to be point, so there is no filtering of the edges, so we can see clear, crisp pixel art. And lastly, we want to select the color format and set it to the sRGB at the top, so that instead of seeing washed out colors when we import our work into other software, we would see the same accurate colors that we have seen in Unity. To display our texture, we are going to use the UI Toolkit. To do that, in the hierarchy, we are going to use this plus icon, select the UI Toolkit, and we are going to select UI Document. In the inspector, select the UI Document component and select Panel Settings. Here we are going to select this asset, and in the inspector here we can set the scale mode to be scale with screen size. Now we can input the resolution. The desired one will be 1920 by 1080 in my case. And with this done, we are going to go to the Project tab, right-click, Create. We are going to go down to the UI Toolkit, and we want to create UI Document again. Now this will be an asset. We are going to call it Drawing UI. When you create it, just double-click on it, and the UI Builder should appear. There is a hierarchy on the left. Just select a drawing UI.uxml, and on the right you can set the size. So again, 1920 by 1080, and in the center we can select Fit to Viewport to see the whole screen. We do not have anything in our scene, but if you would like to see the camera view, we would select on the right the canvas background, and we would select the camera here and select our main camera, and we can see the background color that I have set. On the left, we have containers and controls. We want to drag a visual element container into our hierarchy, and we can right-click, rename it to be canvas. We will need to have it because now we can reference it in the script. The name canvas. Here, all we need to do is go to the right in the inspector. We need to find the background tab, and here we are going to set the image not to be texture but render texture, and we can select the cog icon and select our new render texture, and this will be drawn in our canvas. We want to select the scale mode, and we want to find the scale to fit, and this is the last option here. Now our texture should fit our canvas, although there is nothing right now to render because the texture is empty. Lastly, from the controls on the left, we are going to drag a button, and we are going to select it and call it clear, just so that we can clear our canvas when we have something on it. We want to go to the inspector, find the position tab, and we are going to select position mode to be absolute, and now the button will be separate from our canvas. Now, for the button, we want to go to the inspector, and for the text, we are going to just type clear. And for clarity, at the bottom, select the text, and we want to give it size 28, and the text should be bigger. I think that's pretty much it. So at the top, we are going to select File and Save to save our UI. Just close the UI Builder, and in the hierarchy of Unity, select the UI document, and we now need to select the source asset. Let's select the cog icon, and we have our drawing UI. And we should see our button showing up in our game preview, although the texture is still empty, so nothing is showing. Make sure to set the game resolution to 1920 by 1080. So to show our render texture, we are going to create a new script. Select Assets folder, right-click, create a new monobehavior script. Let's call it DrawingRenderer. I have added the fields that we need. So first of all, we need to have a serialized field private RenderTexture m_RenderTexture, so we need to reference this texture to be able to draw on it. Now, to be able to draw on the RenderTexture, we need to create intermediary mDrawingTexture, so we can first apply changes to our texture 2D and next apply it to the RenderTexture. Now there is nothing stopping us from drawing onto the UI the texture 2D directly, but this way we have separated the drawing renderer from our UI because both UI and this drawing renderer, so our scripts, will reference the asset render texture instead of knowing about each other. Lastly, we are going to store the colors applied to our texture 2D and the render texture. Next, we need to set those up. So I'm going to create a start method. And here, first, we are going to select the drawing texture, so the texture 2D. And we need to instantiate it to be a new texture 2D, passing the width and height of our render texture and setting the texture format to RGBA32. And we are going to set the MIP chain to be false. Next, we want to set the filter mode of our texture 2D to be filter mode point so that there is no blurring. And lastly, we are going to set the pixel colors array to be of the length width times height. So we are going to have a 1D array and we are going to use it to apply colors to it. In this for loop, we are going to just assign black color to each pixel. And next, we are going to create this update render texture method. Now to read or write to our render texture, we need to set it as active. So here is an example where we save the previously set to active texture. And next we set our render texture to be active and apply changes to it using a texture 2D reference. So in our case, we want to draw to this render texture. So in our update render texture method, we want to save the previously set to active render texture. We want to set our render texture to be active. We want to apply the pixel array that we have to our texture 2D. This is this step. Next, we call apply to draw to our texture 2D all the pixels. And when we are sure that they are applied, we want to use graphics.blit. And we pass the drawing texture. So this is our texture 2D. And the render texture. So this is our render texture. So we draw our black pixels onto the render texture. And next, we restore the previously set active texture, which very well might be null. Now this graphics.blit just uses shader to copy the pixel data onto our render texture. All we need to do is in the hierarchy, let's create an empty game object, call it DrawingRenderer. And let's apply our script here. And we need to assign our render texture using the cog icon. We are going to assign our render texture. Let's save our project and let's just press play. If everything went well, our render texture now is black. You can select in the project tab the render texture and you should see that now it is a small black square and it is showing up in our game view in our UI. We can stop our game and the render texture stays the same because we have applied those pixels, so it will be black until we clear it. Now we need to be able to draw on it and also use this clear button to clear it. What we first need is to be able to communicate with our UI. So let's right click in the project tab, create a new mono behavior script. Let's call it UIController and let's open it up. To connect to our UI Toolkit, we need to create a private UI document. And this is from the Unity Engine.UI elements. And I'm going to just call it me_UI document. And we are going to create private visual element. And this will be our canvas. And we are going to also have an _button or clear button. Now, to be able to relate the informations if we have clicked on our canvas or clicked our button, we are going to use events. This will be public event action delegate, and we are going to just send those events. First one will send the vector to position. This will be on pointer down and on pointer moved, which we will use for drawing. And we will also have a public event action without sending any parameters, and this will be on clear button clicked and on pointer released. Now to make this all work, we are going to create awake method, and here we are going to just access UI document equals get component UI document. This is on our game object on which our script will be attached to. Now to access the visual elements, the GitHub Copilot has suggested that we use UI document.root visual element Q for searching the visual element, and we are going to access canvas, and this is the name that we gave to our UI element inside hierarchy in our UI builder. So in our code, we need to search for canvas with capital C. And for the clear button, it will be the same code, but we are going to just search for clear with capital C, or depending on what you have named your visual elements, this will be this name. Now to connect our action events to our UI elements, we are using 𝑚_canvas.register_callback, but not to only support mouse, but also, for example, touchscreen. We want to use pointer down event, and this will be the same pointer move event and pointer up event for our canvas drawing. And to handle the situation where our mouse cursor goes outside of the canvas, we want to use 𝑚_canvas register callback, and we are going to use pointer out event, and this will be on pointer out event. If you are using Visual Studio, you can right click and just use quick actions to generate those methods. Okay, and for the button we are using click event and the same register callback method, and we're just going to do the same, generate this method. And in most cases we are just going to call on clear button clicked !invoke to call this event if any method is assigned to it. We didn't define the on pointer out event, so let's call on pointer, and we can call out !invoke, and we need to just create it in the actions on pointer out. Okay, and for the rest of those we can just debug.log the local position using this parameter. And just to show you how it works, we are going to just debug.log in all of those 3 events that are already connected to our canvas. Let's save our script. Let's go to Unity. In the hierarchy, select your UI document and just assign to it the UIController script, and now press play. If your script is working, you should see debug.log values, but the interesting thing is that while in the top right corner the values are smallest, so we are going to go to the top right corner and the values are nearly 0 and 0, at the bottom right corner we are going to see that the values are actually the highest. So this is the issue with the UI Toolkit, or rather its feature that is rendering Y values downwards. So if we go down, the values gets positive and gets higher. So we need to account for that when we communicate the UI coordinates to our system. So let's reopen our UIController script, and at the bottom we are going to define 2 new methods. First one will be private vector to process position. We're going to get the local mouse position from our event, and we are going to just normalize the position using the normalized pixel position local mouse position. Now the idea here is that we are going to normalize the position in pixel coordinate between the 0 value and the width of our canvas, and the 0 value and the height of our canvas. We are going to have our texture of different size. It can be 16 by 16, 32 by 32, or whatever we set to it. But the UI will always be the same in screen coordinates. So if we know that at the bottom is 0.00 and at the top it is 1, 1, we can scale it based on the size of our texture, and this way we can ensure that we draw pixel values, so pixels on our render texture. If it doesn't yet make sense, it will when we are going to add a drawing. Now, when we have normalized the pixel position to be between 0 and 1, we need to account for the fact that the Y value goes downwards in the UI. So we are going to just set Y value to be 1 minus the value, and we are going to just return this normalized position. And going back to our events, we can just get the position using the process position method. And next we can just debug.log now the normalized position. And next we can create our on pointer down !invoke normalized position, and we can do the same in other methods, but calling different events. So this is on pointer moved, and in the on pointer down event we are going to call on pointer down. Now if we save our script and press play, you can see that at the bottom left we are going to get the smallest values, and in the top right we are going to get the highest values. But the problem is that we are not going to be confined to this area of our canvas, but to the whole screen. So we just need to adjust for that. The easiest way to do it is in the awake, or actually let's create start method just to be safe. And we are going to call 𝑚_canvas style.width. It will be screen.height. Because height is smaller, and the �mCanvas style.height, it will be screen.height. So we are going to create a square out of our UI element. Let's save our script. Let's go back to Unity. And now you will see if you press play that we have the square, and the square is only showing us the positions from 0 to 1. And if we go outside of those bounds, we are going to see 1, So we have limited the detection of the position to this square, but we want to center it. So we need to stop and go back to our UI Toolkit, to our drawing UI. Select our canvas UI element and select in the viewport this icon here. And if we select it, it is aligned self. It should be in the center. Let's save it, file, and save, and let's press play again. And now, as you can see, our square is aligned to the center, and the values are only detected when our pointer is over this square. Last thing that we need is to actually be able to draw on it. First, just open the DrawingRenderer. We are going to select this for loop and the update render texture method. Right click on this quick action, and we are going to extract it and call it clear canvas. This will be a new method. Let's set it to be public. So we are going to reuse it for our button, and we are going to have a new public method called drawOnTexture that will take vector2 normalized pixel position that our UI sends and a color, and it will convert this to our texture position by just multiplying the x by the width of the texture and the y by the height. So this is how we are going to get the position of a pixel on our texture. Next, we calculate the pixel index of our color array, and if the pixel value is equal to this color, we are going to return, because the update render texture method is computationally expensive, so we want to avoid calling it if we don't need to. If this is not the same color, we are going to assign this color to our pixel colors, and we are going to just reuse this update render texture method that we already have. Lastly, to connect our drawing renderer with our UI, we need to have a separate script. Let's right click, create a new script. Let's call it Drawing Manager. Okay, so here we are in the Drawing Manager, which will be managing the connection between the UI controller and the drawing renderer. So we need to have the references to both of those objects. In the start, we are going to connect our UI controller to the on pointer down, on pointer released, and on clear button clicked. 3 new methods: start drawing, stop drawing, and clear drawing. Clear drawing is the easiest because we are going to just call drawing renderer clear canvas, and this will be connected to our button. Now, when we want to stop drawing, we are going to unassign from the UI controller on pointer move the draw method. The draw method just takes the vector2 normalized pixel position and passes it to the drawing renderer drawOnTexture, passing the vector2 and the color yellow, or if you want to expand it, any color that you are going to pass here. And the start rendering will just call the draw method and will assign us back to our on pointer move method. So when we click and hold our button, we are going to continue drawing, and when we let go, we are going to just stop drawing. Okay, make sure to save this script, and let's go back to Unity. Simply create in the hierarchy a new game object drawing manager. Let's assign to this a new script that we have created, drawing manager. To it, we are going to assign UI document as the UI controller and the drawing renderer as drawing renderer. And let's just press play. Make sure that you have full HD set in your game resolution, and now you should be able to draw your pixels correctly. Now, we have 2 bugs. One, that if we let go of our mouse button, it will keep on drawing. And the second one, if we go outside of the area and go back, it will keep drawing. So let's fix those. My first bug is in the UI controller. When I have registered on pointer released event, I have used on pointer down. So I wanted to call here on pointer released. Okay, let's save it. And the second problem is inside the drawing manager. And we have this on pointer out event that we haven't assigned to anything, so I need to assign it to the stop drawing. Let's save this, let's press play again. Okay, and if I now let go of my mouse button, it stops drawing. If I hold my mouse button and go outside of the bounds of my canvas and go back, I am not drawing anymore. I need to let go of the button and draw and click it again and hold it. Or we can just click in different spaces to draw, and the clear button should also work. Now, for more advanced features, so for example, selecting the color when drawing, we can add something like color square that uses hue, saturation, and value, and this uses the same logic as our canvas. So we have a render texture here, and we can click on it and select our color. A color selector script is using this generate color square method, loops through each pixel of our texture, and generates a different color based on the hue value. Now, the set color based on the vector2 position, so the normalized position of our render texture of the color square, just selects the color based on our color array and set it as our currently selected one. Eraser tool is the same as the brush tool, but it just sets the color of the pixel to the color clear, so it sets the pixels to be transparent. The grid background of our canvas uses again the same logic as our texture for the canvas or texture for the color picker. We just have a grid renderer script that uses two colors and renders a checker pattern onto the texture. For more advanced tools like this square drawing tool or for example the line drawing tool, we can create a specialized class. This takes in the start and end position and uses an algorithm created by someone smarter than me on how to draw a line between two pixel positions. Now, to make it easier to add more tools, I have defined an abstract class drawing tool that defines some methods that are used by most of the tools. And inside the drawing manager, I just store the reference to this tool, and it is set when the UI is clicked, when the button of the tool is clicked, and we just instantiate a new tool and connect the specific UI events to this tool based on what type of tool it is. If it is a tool that draws between 2 points or a tool that draws constantly like our brush or our eraser. For the details of the implementation, check out my project template. I hope this was helpful. Thanks a lot to my Patreons for your support. Take care.